Alright, so today's lesson will be on standards of measurement. Now, there's a very specific reason why we have to have standards of measurement. Um, it may be obvious to you, but if you were going to try to measure, for instance, whether or not a couch would fit through a door, you wouldn't want to use your hand as a measurement if your hand isn't exactly the same length as your friend's hand. It might be good for estimating the length to get through the door, but it's definitely not good in science where we need precise measurements. So, a standard is an exact quantity that people agree to use for comparison. When you're measuring things, you use a ruler. You don't typically use your hand unless you're trying to estimate or something like that. So again, a standard is just what we call something that we can compare everything to. So I kind of just explained this, but why do you just to reinforce this? Why do you think it's important to use a standard for measuring? Give you a minute to talk to your partner to answer that question. Okay. So now that we're talking about measurements, I want you to think about this statement here. Say you're trying to get from one place to another. Would it be helpful if the guy in this farmhouse up here, for instance, would it be helpful if he told you, oh yeah, to get to where you want to go, you just drive 7 down this road? What's wrong with that statement? Hopefully you realize that just saying a number isn't very helpful. Just like saying I need 5 of string. Um, do you need 5 yards of string? Do you need 5 meters of string? Do you need 5 inches of string? What does that number mean? Do you want to drive 7 kilometers down the road, 7 miles down the road? That's why it's important when you're talking about measurements, when you're answering questions, that all your measurements include a number and a unit. And we're going to talk about the different types of units, but all measurements must contain at least those. So there's many different sets of units. America has its own set compared to many countries around the world. Uh, but the set we're going to use in science is called the System International, which is a system that was derived in France. Um, Basically, what that means is that scientists around the world can compare their measurements to one set standard. As you can see in the background, there's the standard for a kilogram. This we'll talk about in a second, but this is actually a unit of mass. So SI is short for System International, and it is basically an improved version of the metric system with more accurate standards. So each SI measurement has a base unit, which we'll talk about here. These 7 quantities here are the base units for the SI system. Uh, you've got length, which is measured with the meter, and to the right is what each one is abbreviated with. Mass is measured by the kilogram. Time is measured by the second. Those are the main things we'll be studying. We'll also look into electric current, which is measured by the ampere. Thermodynamic temperature is Kelvin. Um, More chemistry topics will be amount of substance, which is measured in the mole, and luminous intensity, which is measured by the candela. Some prefixes, this means is instead of saying things like 200,000 meters. An easier way to say that would be 20 kilometers. What this does, what these prefixes do, is if you tack them on the front of a base unit, it's basically multiplying the base unit by that number. So kilo basically means the same thing as 1,000. If I put that in front of meter, it means 1,000 meters. Just like on your computer, if you've heard of bytes and megabytes, mega means a million. So if I say megabytes, it means 1,000,000 bytes of storage. On the other hand, if you go down the list here, centimeters is 100th. So then 1 centimeter is 100th of a meter. Over on the far right here, you'll see the symbols that you can put in front of the base unit for each of those. So this is based on the multiples of 10, if you didn't catch that already. So let's just look at this. How many meters are in 1 kilometer? Like I said, if you take the K, which means 1,000, you know that that's one. You kind of read this literally. It's 1,000 meters. So since 1,000 milliliters are in 1 liter, if you go back to our chart here, milli means 1,000. So it's 1,000th of a liter. That means 1,000 milliliters can fit into 1 liter. Since milliliters are smaller, a lot of them will fill up 1 liter. Since these are the same thing, just like if I were to divide the number 3 by the number 3, or the number 6 by the number 6, since 1,000 milliliters and 1 liter are the same thing, I can get the number 1 when I divide them. That's why I can multiply any number by this and get the same value afterwards. For instance, let's look at this sample problem here. We've got how many milliliters are in 1.255 liters? So we know we have 1.255 liters. What I can do is multiply 1,000 milliliters divided by 1 liter. Now, since this is equal to 1, it's basically the same thing as multiplying 1.255 liters times 1. I'm allowed to do that, right? Except I want my answer to be in milliliters instead of liters. So when we do this, what happens is our units on the top and bottom are canceled out. Because like I said, I'm dividing liters by liters. Those are going to cancel out and give us 1. So what I can do is I can multiply 1.255 times 1,000 and get 1,255. You can also think of it as, you know there's going to be more milliliters than liters because milliliters is a smaller unit. Therefore, you're going to multiply by 1,000 to get a bigger number of milliliters. So let's try this one. How long in centimeters is a 3,075 milliliter rope? Well, we want to take 3,075 milliliters, multiply it by, let me write milliliters here. Multiply it by something over millimeters, so our millimeters cancel out. And we want to get our answer in centimeters, so we want centimeters here. This might seem confusing, but once you get into converting factors, once you get practice, it will kind of make more sense. You always want the unit you're getting on the top and the unit you're getting rid of on the bottom. So let's look at our base unit. How many centimeters are in a meter? 100. How many millimeters are in a meter? 1,000. In this case, I can actually cross out some zeros and basically end up dividing it by 10. In other words, I'm multiplying it by 100 and dividing it by 1,000, which ends up being like dividing it by 10, which means I have 307.5 centimeters. So go ahead and try this on your own. Pause the video and work this out. Figure out how long your pencil is in millimeters if it measures 11 centimeters. Okay, so hopefully you listened to me and paused the video and figured this out on your own. But if you had trouble with it, let's go through it right now. So we have 11 centimeters is our known value. We're going to multiply that by something. We want it in millimeters. So millimeters is going to be on top, centimeters is going to be on bottom. So I do, how many are in my base unit? 1,000. How many centimeters are in my base unit? 100. Again, I can cheat and cross out zeros on top and bottom, and I end up with 11 times 10 basically. My centimeters top and bottom cancel out, and I get 110 millimeters. Hopefully you were able to receive that answer. Now, we already hinted about this, but length is a measured unit. Length is rather measured using a unit that's appropriate for the distance between 2 points. So, for instance, if I wanted to measure the point between here and here, it's a distance of 19 centimeters because it's between the 24 and the 5 mark. So let's just think about this. Am I going to want to measure a paperclip in meters? Am I going to want to measure it in kilometers? Probably not. Think about what unit I would want to measure the length of a paperclip in. Now, if you said centimeters, I would guess that that's a very good unit, maybe even millimeters. But now think about measuring the distance from your house to your school. Would you want to measure that in centimeters? Probably not. You're probably going to want to measure that in kilometers. Now, another value we want to look at is the volume. Now, volume is the amount of space that something occupies. So, the way to measure volume of different things, when we have a solid, all you have to do is take the length. So we'll say this is the length times the width. So we'll call this the width times the height. Which we'll say is this. If I do length times width times height, I get the volume of that box. Now volume is measured in centimeters cubed because I'm multiplying centimeters in length times centimeters in width times centimeters in height, which is the same thing as centimeters to the third power. Measuring the volume of a liquid is a different story. Liquid doesn't have a definite shape. Liquid will take the shape of its container. So when I measure the volume of a liquid, I'm really measuring the volume of the container in which that liquid can be placed. Graduated cylinder or this measuring glass will tell us what the size of those containers are based on where the liquid lands. And remember, whenever you're measuring a liquid, you want to make sure you're getting eye level with your measuring device. The liquid's going to coheed to the walls, you want to make sure that you measure at the bottom of this curve, which is called a meniscus. You want to make sure that you measure the bottom of that, not where it's at on the walls. So always measure at the bottom of the meniscus at eye level. Now the SI unit for, this should say volume. The SI unit for volume is the liter. Now just by definition, 1 milliliter is the same as a cubic centimeter. So keep that in mind. Now another base unit we have is mass. Mass is measuring how much stuff there is, how hard it is to move something. It's the measure of how much matter there is in an object. And that's measured in grams, kilograms, milligrams, centigrams. Those are all measures of mass. I don't get mass confused with weight. We'll talk about the difference later. But mass, just remember, is how much stuff is in an object. Now density takes it to another level. Density tells us how much mass there is per unit volume. Now in the background you see a density column with various materials such as soap, corn syrup, water, rubbing alcohol. Now the most dense liquid is going to end up on the bottom, and the least dense is going to end up on top, because this top liquid is actually lighter per volume than this bottom liquid. Think about a bowling ball and a tennis ball, or let's look at two things that are the same size. Think about a bowling ball and a styrofoam ball that's the same size as the bowling ball. Obviously, the bowling ball is going to weigh much more than the styrofoam. That's because there's more mass packed into that volume. The same with these cubes here. There's some of these cubes are going to be heavier, even though they're all the same volume. Some of these cubes are actually going to have more stuff packed into them than the other cubes, which doesn't have as much stuff packed in. So they're heavier per unit volume, meaning they're more dense. We can actually calculate the density of an object by taking its mass and dividing that by the volume. So if we had something that had a mass of 10 grams and a volume of 2 centimeters cubed, 2 cubic centimeters, we could take density equals mass divided by volume, get 10 grams divided by 2 centimeters cubed, we end up with 5 grams divided by centimeters cubed. Now that's a really funky unit, grams per centimeters cubed. What that's called is a derived unit, because it was taken by taking the unit of mass and taking the unit of volume and putting them together. A derived unit is called that because it's derived from different SI units. There's all sorts of derived units in physical science, which we'll get to later, but these are not base units, they're derived units. Finally, a couple more things we'll measure in this class. Time you're familiar with. You're probably watching, waiting for the time to pass right now. Well, don't worry, because this lesson's almost over. But time is the interval between two events. It's measured in seconds. You'll be using a stopwatch often in your labs. Temperature is our last unit we're going to look at today. Temperature is basically a measure of how hot or cold something is. So something that has a high temperature is obviously much hotter than something with a low temperature, But there's actually 3 different ways to measure temperature. We've got the Fahrenheit scale, the Celsius scale, and the Kelvin scale. You might be familiar with Fahrenheit and even Celsius. Kelvin is actually the SI unit for temperature, and I'll explain that in a second. The reason is because negative 273 degrees Celsius is the coldest an object can be. That means that the molecules in the object are totally still. Nothing can be colder than negative 273 degrees Celsius, which is the same as saying negative 460 degrees Fahrenheit. So scientists decided to make that temperature 0. That's why 0 Kelvin is absolute 0. Now, water, what's nice about the Celsius scale is that water freezes at 0 and boils at 100 versus these 212, 373, 32. All those numbers are hard to memorize. So that's what's nice about the Celsius scale. But just remember, to get from Celsius to Kelvin, all you have to do is add 273 to your measurement. That's all I have. I just have a couple sample problems for you. How would you convert 27 degrees Celsius to Kelvin? Hopefully the answer you got is 300 Kelvin. Finally, the other question I have for you is, what is the density of a metal with a mass of 158 grams and a volume of 20 milliliters? Hopefully you said 7.9 grams per milliliter. That's the end of our lesson today. Thank you very much, and I hope that you have a better understanding of how our units of measurement are derived and how they relate to one another.